what we're looking at here is how to determine equations from graphs. Now, I'm not sure what these are, so hopefully they'll be something a bit weird, but we'll find out soon enough. So basically, all we need is, it depends on what information we've got in terms of which way we go about it. Here we've got, so we're going to look at these two here. If we've got, basically we need at least 2 points. If we've got two factors, so if we've got the two x-intercepts, we need one more point. Doesn't matter what that point is. If we've got a turning point, well, then we only need one more point. So let's have a look at this. So we've got this thing here. So we're looking at this first one here. We've got x-intercepts at -1 and 3, and then we've got another point here at 2 and 3. So that's the information we're going to use. Now, because we've got the two x-intercepts, we can use factor form. So we're going to say, whoops, where's Kaz? So a new calculator, and you can do this on paper, but we're looking at how to do it on CAS. So we know that our factor form is written as a x minus b x minus c. So that's what we've got there. Now we have a look at our two intercepts. We've got one here at -1, so we'll say a x minus -1, and we've got another one here at 3, so that is x minus 3. And I'm going to put a times here, so that we know it's a variable. I'm going to write that down. So that's what we've got there. So we've got a times x minus 3, so that's one factor, x plus 1 is the other factor. Now what we need to do, we need to solve for a. So what we're going to do, I'm going to write solve, and I'm going to take this, and we're going to use this other point. Now this can be any other point, it doesn't matter. This is a point at 2 and 3. So what we're going to do is, wherever we see an x, we're going to put a 2. And wherever we see a y, we're going to put, oh, we don't actually see a y, but we're going to put a 3. So we're going to say, so here, instead of x, we're going to write 2. So I'm going to change that with a 2. I'm going to change that with a 2. And I'm going to say equals our y value, which is 3. So I'm going to say equals 3, and I'm solving for x. Oh no, I'm not solving for x, I'm solving for a, because that's our unknown, that's what we're solving for. So it tells us a is equal to -1. So based on that, I'm going to take this, and I'm going to say -1 times all of that, and then I'm going to expand, because we may want it in general form. And there it is there. And then to check it, what we do is we'll go to CAS, we'll make a new page, we'll go back to this other one, I'll copy this, paste it in, and there it is. We can check for turning points, analyze graph. We'll check for zeros, whoops. There's one there at -1 and 0. Analyze graph, we'll check for another 0. Here's one at 3 and 0, we'll check for a maximum, which happens here at 1 and, oh no, 1 and 4, that's fine. That's fine, because that is what it looks like we've got here, 1 and 4 there, we're pretty accurate there. Okay, so let's have a look at the other one. So what we're going to do here, I'm just changing venue. What we're going to have a look now with this other one, where we've got information here. Now, we're not actually told what our x-intercepts are, so we can't take that as being necessarily correct. So what we're going to do instead is we will, but we know that we've got a turning point, we've got another point there, so that's the information we'll use. We've got that information there. Now we can see we've got a turning point here at 1 and 9, no, sorry, -9, and then we've also got another point here at 2 and -8. So that's the information we're going to use. So because we've got a turning point, make a new calculator page. We know our turning point form is a x minus h all squared plus k. And we're going to put a times here, so we know it's a variable. Well, and it gives us that, but this is what we're interested in, so don't worry too much about all this. This is the part we're interested in. So what we're going to do now, like what we did before, where we've got our h, that's our x coordinate. So we're going to say we're at 1, so we're going to say minus 1. We're going to leave that there. And then we've got our y coordinate at -9, so this will become -9. So that's what we've got there. And now, once again, we're going to take this, I'll say solve, I'm going to take this, and we're going to use the information from our other point. So we're going to say here we've got our other point at 2. So wherever we've got x, we're going to write 2. So I'll say 2 minus 1. And then this equals negative 8, because that's our other point. 2 and negative 8. Negative 8. And we're solving for a again. And tell us that a is equal to 1. So we'll take this. Instead of a, we'll write 1. And that's what we've got there. And then we'll graph that. So home, graph, go back to the other one. Copy that. Paste it. And we'll just check to make sure we've got the right information. Menu, analyze graph. We're looking for a minimum here and here. It's at 1 and negative 9. We also know that if we draw a negative 8, we should intersect here at 2 and negative 8. We'll check that as well. Intersection. And then we have 2 and negative 8. So that's the way we go about finding that. So let's do a bit of a recap. So it depends on what information we've got. If we've got factors, if we've got x-intercepts, we put those into our graph. Remember, intercept form, a times x minus b, x minus c. Whoops, that should be a c, not a v. And then we substitute our values. Whatever our values are, we substitute them in. Negative 1, 3 is 3. We substitute that in, we end up with something there. And then we substitute our x values for our other point, and we let that equal the y value at that point. We solve for a. And then graph to check. If we've got turning point, remember this is turning point form. We substitute our x coordinate for the turning point, y coordinate for the turning point. And then we substitute x and y, and we solve for a. Once we've got that, we substitute a back in, and then we graph just to check. And they're the steps that we take.